A half-life of cesium-137 is 30 years. Suppose we have a 10-gram sample. Find the function m of t equals m sub 0 to negative t over h that models the mass remaining after t years. The half-life in this case is 30 years, so h equals 30. We have 10 grams to start out with, so the initial mass is 10. Therefore, the equation is m of t equals 10 times 2 to the negative t over 30. The parameters m0 and h are provided in the problem. T is the variable of this function mass. Part B. Find the function m of t equals m0 e to the negative r to the t power. The simplest and the easiest way to do this, now that we have the half-life equation, is to compare the two. The equation we just found is m of 2 equals 10 times 2. Rewrite it, we have 1 over 30 times negative t, or t times negative 1 over 30. The equation that we're looking for is m of t. The m sub 0 is still the initial value, so it has to be 10. E, negative r is the parameter we don't know. T is t. By comparing the two functions, it must be the case that 2 to the negative 1 over 30 has to be e to the negative r. Everything else match 10, 10, t, t, and so the expression 2 to the negative 1 over 30 has to be the same as e to the negative r. The goal is to find r because for this equation, we need to find the parameter m sub 0, which we know that it is the initial value 10, but we also need to find r. We then ln both sides of the equation to get ln of 2 to the negative 1 over 30 equals negative r. And so r is negative ln of 2 to the negative 1 over 20. This is approximately 0.0231. And so the models that we're looking for is m of t equals 10, e negative 0.023 t. Both of these equations will give us the same answer. We will derive this equation at the end of this video, but it is better to use this formula because it reminds us of 2 to the negative 1, which is 1/2. This is the half-life model. How much of the sample will remain after 80 years? 80 is the number of years, so we just simply plugged in to t. T is 80. The right-hand side is 10 times 2 to the negative. T is now 80. And then divided by 30. But in the calculator, we will get 1.5749, or roughly 1.6 gram. How many years after will only 2 grams remain? The mass is now 2 equals 10 times 2 to the negative t over 30. How many years? We're looking for t. We divided by 10 both sides of the equation to get 1 over 5 equal 2 to the negative t over 30. And then we ln both sides of the equation because we want to get to the variable unknown in the exponent. Ln of 1 over 5 equals negative t over 30 times ln of 2. And so t equals 30 times ln of 1 over 5 divided by negative ln of 2. And so we undo everything and just leave t alone. Put this in a calculator, we will see that this is roughly 69.658, or simply 69.7 years. After 69.7 years, or almost 70 years, there will be 2 grams remained. We now find this equation by finding the parameters m sub 0 and r, given the half-life is 30 years and the initial value is 10. M of t equals 10 e to the negative rt. We update the equation right away once we have any of the new information. We still need to find r, but we were told that the half-life is 30 years. What that means is that if we were to start with 10, after 30 years, we should end up with 5 half-life. To find r, we divide by 10 from both sides of the equation, so 5 over 10 equals e to the negative 30r. This is 1 over 2 equals e to the negative 30r, and so we ln both sides of the equation to get to negative 30r. The left-hand side is ln of 1/2, and the right-hand side is now negative 30r. r is ln of 1 over 2 divided by negative 30. If we were to put it in the calculator, we'll get r equals 0.0231, and so the equation is m of t equal 10 e to the negative 0.0231t, which is the same equation we got earlier.